Hi everyone, I'm going to talk you about our expert system. This project is an expert system for animal detection using clips. This project is made by Adrian Morales and Andres Tello. Introduction to expert system. Expert system is a system that uses human knowledge captured in a computer to solve problems that normally require human experts. Expert systems are computer systems that simulate a process of learning, memorization, reasoning, communication, and action in consequence of a human expert in any branch of science. The process allows you to store data knowledge, draw logical conclusions, make decisions, learn from existing experience and data, communicate with human experts, explains the reasons for decisions made, and take actions as a result of all the above. Application, as can be in the figure, economics, industry, and medicine continue to be the domain fields among those which expert systems are used. Education, transport, space, military, science, engineering, medicine, industry, and business. The parts of an expert system is given three parts: fact-based, interface engine, and knowledge base. Fact-based, also known as a working memory or global database, is the one that contains the data input criteria. It is updated during the execution of the system. Inference engines is the control program whose function is to select the possible rules to satisfy the problem. Knowledge base a set of rules that allow the represent knowledge of the expert domain, where each rule has its own meaning. Normally, knowledge is declarative, so the knowledge base is almost always a description of the knowledge of expert and requires some mechanism that obtains the appropriate inference to solve the problem, be able to select rules and execute them. The interface engine. Why to use an expert system? It helps people with little experience can solve problems that require a specialist form of knowledge. Expert systems can draw conclusions and solve problems faster than human experts. Expert systems reason but based on accurate knowledge and have no place for subjectivity. It has been proven that expert systems have at least the same competence as human specialists. Our program description. Our expert system determines the animal in which we are thinking, based on some questions such as size, color, and other specific characteristics of the animals that we have registered in our database. We have registered musil, moose, javali, and other animals. It can be add more animals. Up next, my partner Adrian is going to talk you about the source code.
Hello, my name is Adrián Morales and my friend Andres Tello. We are talking about the expert system of animal classification. For this expert system, we use clips. In this template definition for the animal, the file has the following form. The template animal and type checking is applied on every file. Some files have a number of always value for safety, and the name, kind, and size, all three are required files. Size is strictly a number, float or integer. Description in three separate parts. Color is required, spot and body are optional. That environment is a required file. We used animal database with 12 animals with number, kind, size, colors, spots, body, environment. We can see the database. Uh, we use a global variable that holds the number of available animals. The variable above is being modified with this function. Each the time we exclude an animal from the possible solutions. The function minus 1 or minus 1 decreases the global counter by 1. This function is used for every question made to the user. The question that is printed to the user is broken into the three arguments: kbeg, kmin, and kend for flexibility, as we may need to include a printable in the middle. The argument all with values is in the list that holds that all values that the program accepts. If the user enters a non-acceptable value, the program asks the question again until the answer is valid. This is the function pedir pregunta, la variable qbeg, qmid, and qn. For the def rule pregunta print tamaño, the first main question that made to the user we ask from the size of animal, expecting tiny, small, or big as the answer. The result is stored as the following fact: scale, size. This is the fact scale. Given that the fact scale exists, this rule gets triggered. This rule filters the animal by size and deletes those that are not in the given scale group. In addition, every time we retrieve an animal, we subtract 1 from global variable counter, calling in the -1 function. The second main question is about the color of the animal. The user can type any color from the acceptable list in the parentheses. The result is stored in the following fact: the color. The main question, color, and stored in the fact color. Well, then give the fact the color exists, this rule gets triggered. It is very similar to the filter by scale rule o filtrado por tamaño. This rule filters the animal by color and deletes those that do not have this color in the list of colors. In addition, every time we retrieve an animal, we subtract 1 from the global variable counter and call in the -1 function. After a scale and color filtering process, we check the global variable counter. If we have one animal left, this is the result and we assert found true in order to trigger the success print rule below. If we have 0 animals left, we assert found false, as there are no animals that pass the filtering. If we got more than 1, we need more facts to reach a conclusion. So we assert need more facts o necesita más hechos. The arguments scale and color for the program to continue asking. Give the fact, need more facts, where S is the scale and C is the color the user has asked. We ask a more specific question about the animal that we were searching. When they search a fact in the following form, ask X and Y, where X is the file of the animal template and Y is what we are searching in X. Based on the search that was made on the rule above, we ask a specific question about the body of the animal. This is the depth rule for the question of the body animal, and there will be only two possible choices when the question is about the body of the animal. We pick those two facts, make sure that are different, and ask the body question. The rule follows the same idea of the rule about two possible animals and get filtered, and we got a solution. This is the rule preguntar ambiente of the animal. The rule preguntar manchas. This rule follows the same idea that rule above, but instead of two animals, we have three. We ask if the animal has spots based on the analysis table. If the answer is yes, we get a solution and we assert found true. Otherwise, answering no, we get two possible animals and we need to ask one more question. This we assert as a particularly dangerous. The rule preguntar particularidad. This rule gets triggered if the previous one, as spot or preguntar manchas, was triggered and the fact as particularly dangerous is present. Other than that, it follows the same idea as the rule above, where we only have two possible animals. For the death rule, coincidencia encontrada or match found, in the fact found true is present, it means that we have only one animal fact in the memory. This we have concluded to the one the user searched for. We assign the animal to the variable any and print it is name and kind to the user. For the demonstration, we reset the program. We initiate. This is the database of animal and run. If the animal is tiny, small, or big, we type tiny. What is the color? Mm, um, Yellow. Has the animal tail of the body? No. Animal phone is the spider. Type Opcovis annubilis. For the animals small. What the color is, um, in this case we don't have colors and need more facts. We try again. Mm, green, very green. Animal phone, grasshopper. We reset the program, run, and now with big animals. Mm, gray has the animal, tentacles, and the body. Yes, we type C. And animal phone. This is the expert system of classification animal.